Today we're going to learn how to get the molecular formula from the empirical formula. Succinic acid is a substance produced by lichens. Chemical analysis indicates that it is composed of 40.68% carbon, 5.08% hydrogen, and 54.21% oxygen, and it has a molar mass of 118.1 grams per mole. Determine the empirical and molecular formulas for succinic acid. So, here, as you can see, the only difference is that they are giving you a molar mass. Now, what is this molar mass and what are we going to use it? Take a look at these new equations. We have a molecular formula factor, okay? This formula tells me that I will divide my molar mass of my molecular formula, which is the one given, divided by the molar mass of the empirical formula. That we don't have it, but we can get it because we have the chemical composition of it. Now, how can we get the molecular formula? Multiplying the empirical formula that we got, okay, the procedure that we just know already, times the factor that we're going to get from here. So, this exercise involves two calculations, empirical formula and molecular formula. So we're going to begin with this exercise like regularly, okay? Like we used to do it before. So what do we have in the first step? In the first step for empirical formula, we have the percentage composition to become grams. So, even if the problem is not telling you that it's 100%, I always suggest to add all the percentages to make sure that you actually have 100%. So that's what I'm going to do right now. 40.68 plus 5.08 plus 54.24. There you go, 100%, so we are cool. Now, let's see. We have, in the first step, remember what we do is from percentage to grams. Okay, so that is the first step. So we have 40.68% carbon. Now it's going to become 40.68 grams of carbon, 5.08% hydrogen. It's going to become in 5.08 grams of hydrogen. Then we have 54.24% oxygen. This will become 54.24 grams of oxygen. Now, what I'm gonna do is the second step. Number of moles. Okay, how can I get the number of moles? By dividing by the atomic mass, okay, or the molar mass of the individual elements. So this will be carbon divided by 12.011. It's the same process that we did before, okay. Hydrogen will be divided by 1.0079. and oxygen will be divided by 15.999. This will give you the number of moles. How much you'll get? I got 3.39 moles of carbon. I got 5.04 moles of hydrogen, and I got 3.39 moles of oxygen. Now, what comes next? In the next step, what we have is we need to divide by the smallest ratio. What is the smallest amount of moles that we got? As you can see, we got 3.39 twice. So we're going to divide by 3.39. So this is divided by the least. So we're going to be dividing by 3.39. How much you get? Example, here and here I know that I will get 1. Now here 5.04 divided by 3.39 gives me 1.49. Okay, now 49, it's close to one number, really close to one number. Okay, so we need to round. In the next step, if we need to round, we do it. Okay, in this case, as you can see, yes, we can round. So this, it's already 1, so we don't need to. This is approximately equal to 1.5, and this is 1, exactly 1. We don't need to round it. 1.5 or 1.50 if you want to take a look better to 50 instead of 5. From 49 to 50, you're missing just 0.01, so we are very close. And now take a look, we have a decimal. So the other day I told you that if you had a decimal, that you have to multiply by a factor. Okay, so my decimal is 0.50, so I will consider this to be my factor, okay, my multiplication factor. So what we do is we're gonna multiply everything times, in this case, 2. So this will give me my next step, that is the empirical formula. So 1 times 2 gives me 2, 1.5 times 2 gives me 3, and 1 times 2 gives me 2. So that means that my empirical formula actually is 2 for carbon, carbon 2, 3 for hydrogen, hydrogen 3, and 2 for oxygen, oxygen 2. Now, this is the empirical formula. This is a process that you already know so far. Now, it is good because for the now for applying the new formulas, you need to get the molar mass of the empirical formula. This one is given, but you need to get this one, okay, the empirical formula molar mass. So we need to get it. So this will be, the molar mass will be carbon, hydrogen, oxygen, 2 times 12.011, 3 times 1.0079, and 2 times 15.999. This gives me a molar mass of 59.04 grams per mole. Okay, this is my molar mass of my empirical formula. Now, you have this. Now we can get the factor. Okay, how can we get the factor? Dividing the molar mass given by the molar mass that we just got. So that this will be my 6th step for that saying. Okay, 6th step is the molar mass of the empirical formula. Now in the 7th step, we're gonna have the factor. Okay, and this is the molar mass of the molecular formula, that is 118.1 grams per mole divided by 59.04 grams per mole. I will cancel these units because they are dividing. Okay, so we're going to divide 118.1 divided by 59.04. Take a look. This factor gives me 2.0003. We're gonna leave it in 2. Okay, we're gonna leave it in 2. And now in my last step, it's gonna be the 8th, the molecular formula. Okay, so this is my molecular formula. How can we get it? Empirical formula times the factor. So my factor is okay? So my empirical formula is this one, right? C2H3O2 times the factor that we got from the step before, that is 2. So my molecular formula is going to be C4H3 times 2, 6, O, 2 and 2, 4. And this is the final answer. Okay, this is the molecular formula and this is the empirical formula.